So we're going to set this up the same way. So we have our denominators. Okay, we have our denominators x plus 7, x minus 7, x plus 2. We're going to split up the fraction into an x minus 7 denominator and separately an x plus 2 denominator. And then we're going to cross multiply that to generate the numerator, which is negative x minus 38. Okay, so I'm going to do a times x plus 2 plus b times x minus 7, and that's going to be equal to the numerator, negative x minus 38. Okay, so I can set up a system of equations again like I did before, but now I'm going to show an alternate method. So this is going to be just an alternate method. To solve for the coefficients. And for these coefficients A and B. Okay, so A and B. Okay, now what this involves is generating zeros. So I'm going to generate a zero by substituting values of x. So I'm going to let x equal 2. Sorry, let x equal negative 2. So what's that going to do? Well, if I do that, I'm going to end up with, in one bracket, negative 2 plus 2. And what that will do is it will generate a times by 0. So this ends up being 0. Now, how does it affect the other brackets? Well, the way it's going to affect the b is I'm going to end up with b times negative 2 minus 7. That leaves me with b. So in this case now, I've gotten rid of the a coefficient. I'm only left with the b coefficient. And when I substitute in for the x being negative 2 in the right-hand side of the equation, I now have only one variable left to solve for. And this is going to allow me to solve for b. So I end up with negative 9b, and that's going to be equal to plus 2 minus 36 or minus 38, which gives me negative 36. That gives me a b value when I solve for b. B is equal to positive 4. So that allows me to solve for b, and I can then do a system of equations, solve for a, but I can also do the same thing to get rid of the b coefficient by generating a zero multiplier. And so I'm going to let x in this case, so that was part 1. Part 2 is to get rid of the other coefficient by letting x equal, in this case it's going to be equal to positive 7. And when I do that, I end up with this. So x plus 2 is now going to be 7 plus 2, or 9a, plus, this is going to be b, times, now it's going to be, since x is 7, I'm going to end up with 7. Instead of x minus 7, I end up with 7 minus 7. That now is going to generate a zero multiplier, so I get that becomes 0. So the b now disappears. And on the right-hand side, I still have the negative x minus 38. Well, the x is going to be equal to 7. I'm going to put 7 into there, so I put 7 in all the x's. The reason why I did that was to generate a zero factor, a zero multiplier that gets rid of the b, and now I'm left with 7 plus 2a, or 9a, is equal to negative 7 minus 38 is going to be negative 45. So I've plugged in where I had x's, Now I'm plugging in 7, generating a 0 factor, which becomes now 9a plus 0 equals negative 45. Well, solving for a now, dividing both sides by 9, I get a equals negative 5. So this is a different method, an alternative method, and this is generating 0 factors. And we do this by choosing some x's that are going to get rid of either the a or b coefficient by generating a 0 factor in the bracket part of that. So this now I've solved for a and b, so now I can write it in its partial fraction form. This is going to be negative 5 over x plus x minus 7, x minus 7, that's going to come from this part, plus this will be 4, b is equal to 4 over the x plus 2, so it's going to come from here, and now I've decomposed my fraction into its partial fraction, so negative x minus 38 is the same as negative 5 over x minus 7 plus 4 over x plus 2.